Okay, so first, sorry for not being with you, and I hope that you enjoy your stay in Finland. So today we'll present a study I did with some colleagues from Finland, from Canada, and from France. So the list is on the slide. And I will talk about the climatic and vegetational controls of Holocene wildfire regimes in the boreal forest of northern Fennoscandia. So the projections show that the increase in temperature in Finland will be mostly like at high latitude. So you have a high increase in temperature in the northern part. But we don't really know what will happen to the vegetation and to the fire regime in the future with this increase in temperature. We don't know if we will have some feedbacks between the vegetation, the potential vegetation changes and the potential fire regime changes. So to better anticipate that, we decided to study what happened in the past, so during the Holocene, and to try to understand what happened during the warm and dry period of the climatic optimum and the cold and moist period of the neoglacial period. So our study area is in the northeastern part of Finland, in the Finnish Lapland, and it's on the geological transition. So you have the Heinäri Craton in the northern part, which is a zone more acid and more moist than in the southern part. And so we have also two other sites on the southern part, Pico and Charlie, and they are on the Lapland granulate belt. So the soil is more basic and drier than in the northern part. And so these three sites are in landscape dominated by pines with some spruces stands, especially in the southern part. So we use climate reconstruction that has been performed by Heikki Sepa and Tomi Liotto. So we use the July temperature from this chironomid-based reconstruction from two lakes in the northern part of Finland. And we reconstructed the fire and the vegetation for both two lakes, the one in the northern part, Rosalia, and Pico in the southern part. So we reconstruct the fire history from charcoal analysis and the past vegetation dynamics from pollen grain analysis. And for the fire regimes, so we use charcoal and we reconstructed different variables. So the biomass burn from charcoal count, the fire frequency from peaks detected by char analysis software. But we also reconstructed the fire size, which has been computed from the biomass burn and fire frequency ratio. So we assume that small fire produced few charcoals per fire and large fire produced a lot of charcoals per fire. And we also try a new method developed by Frodin and Vachula. And that allows us to reconstruct the fire type. So we differentiate the surface fire versus crown fire by using the length width ratio. So we assume that surface fire will produce more non-woody fuel type, so like long and thin charcoal, and crown fire will produce more woody fuel type, so more squared charcoal. So the result for the vegetation, so we see at the beginning of the Holocene for both lakes, an afforestation phase. So the vegetation came back after the deglaciation. And then during the climatic optimum of the Holocene, Scott pine arrived. So later at Rosalia and earlier at Pico, because Scott pine is more adapted to moist and acid soil condition as at Rosalia. Then spruce arrived, so earlier at Rosalia than at Pico, because spruce prefer moist and acid condition. And then during the neoglacial, we have an increase of sphagnum and ericaceae at both sites, but we also see an increase in pollen accumulation rate around 3,000 at Piku. And that can show that we had during this period denser forests. Now concerning the fire regimes, so we've seen that at both lakes we have mostly small surface fire at the beginning of the Holocene. And then during the climatic optimum, we have less frequent but larger surface fire at both lakes. And then during the neoglacial period, we have, again, small surface fires, except at Piku, around 3,000 years before present, when we can see that we had frequent small surface fire, but also some crown fire, because we had a higher proportion of woody fuel, charcoal with woody fuel types. So then we try to understand why we had like a difference in proportion of charcoal with woody aspect through time. So we try to do correlation between this proportion and the variable we reconstructed from charcoal, so for the fire regime and for the vegetation. So we didn't see strong link between the proportion of charcoal with woody aspect and these variables. Not similar trend between both lakes, except for the rock, so the rate of change. And that show that the faster the vegetation changed in the past, the more crown fire occurred, or at least we had like a higher proportion of charcoal with woody aspect in the record. So we can say from this result that warm and dry conditions favored pine, and especially on acid and nutrient-poor habitat has at Piku. And because Scott pine has a self-pruning ability, we likely had a lake of leather fuel during the climatic optimum. So we had mid-large fire because it was warm and dry, but mostly surface fires because we had a lake of leather fuels. And so for the neoglacial during the cold and moist period, we had an increase in spruce in the landscape, mostly on soil with like basic and nutrient-rich habitat, as at Rosalia. And because spruce doesn't have self-pruning ability, we likely had an accumulation of leather fuel that led to more crown fires. But we also saw that like around 3,000 years before present, we also had a dense forest and rapid changes in the vegetation. And so maybe that led to an accumulation of leather fuel, and it's why we had more crown fire, and maybe crown fire also created forest gap that favored spruce. So the feedback between this climate condition, the vegetation, especially spruce, and crown fire during this period are not completely clear in this study. But we can, we have some conclusion about the perspective for future northern Fennoscandia boreal forest. So under warmer and drier condition in the future, we should have more Scott pine and mainly large surface fires. But with greater climatic instability, we could have more crown fire locally and or more spruce locally. But we need further research to better understand the feedback between this climatic condition, the crown fire, and the spruce abundance in this landscape. So thank you for your attention.
Thank you. Yes, Yves?
Yeah. Cécile, without fire, would you
expect or see on the reconstruction a change from pine to spruce with natural succession?
Without fire?
Yeah, without fire. I mean, if there's long period without fire, spruce, pine stem should evolve slowly towards spruce stem. No?
Not really.
Okay, because it's what is happening in Sweden, for instance.
Yeah. The thing is that we spend a lot of time trying to understand why we didn't have the same pattern between Rosalia and Pico, because the lakes are not very far, they are very, very close. But we have like a big lag between the spruce arrival at Rosalia and the spruce arrival at Pico. So maybe that could be due to the fire regime, but we didn't see like a huge difference in the fire regime between these both lakes. So yeah, it's why we try to explain that by the soil condition, because that seemed the logic causes, but we are not sure about that.
Okay, thanks.